If we take a simple LLM setting, we have the user sending some prompt to the LLM and the LLM gets back to the user with a response. So this is fine if the user's query is quite simple, but as the user's query gets complicated, this system won't give the best possible response. One solution could be the LLM takes its own output and thinks about it, or inspects its own output and spends more time thinking about the best possible response, and then gets back to the user with a much more appropriate response. Think of it like responding to a friend versus responding to your manager. If it's your friend, you're just going to respond straight away with some answer. It may not follow the ethics or it may not be very professional, but if you're responding to your manager, you will think twice and you will respond in a much more professional way. So that is exactly what is going on with reflection, and that is the topic of our video today. So reflection can be a simple reflection, or it could be reflexion, or it could be language agents tree search. But today's focus is going to be that of a simple reflection. We are going to be implementing simple reflection in raw Python. So what is simple reflection? So we have the user who gives us the prompt, and inside the agent, we now have a generator block. The generator block is going to generate the response to the user's prompt, but then this is going to go through a reflection block, and the response is going to be inspected by the reflection block, and a feedback is going to be produced by the reflector, and this feedback is going to be passed back to the generator in order to action on its response. And the generate is going to digest this feedback, and it's going to once again generate the response. And this loop is going to go on and on till the system is satisfied with the response. And once the system is satisfied, it's going to get back to the user with a much more better answer. And we are going to implement this in raw Python, meaning that we won't be using any frameworks like LangChain or AutoGen or CrewAI or whatever. And the task that we're going to do is that of generating the best possible code that serves the user. So the generator is going to generate the code for us, and the reflector is going to act more like a code reviewer who's going to give feedback to the generator, and the generator is going to generate better code based on the feedback. And so the task is to generate code. More specifically, the task is to generate code to plot any given data. So the user is just going to give some data, and the agent is going to come up with the best code to plot or visualize that data. And for the implementation, how we are going to go about is we are going to write code chunks in Jupyter Notebook. Once we are happy that each of the code chunks works, we are going to put together everything into an agent class, and we're going to see this class in action. Let's get our hands dirty with coding. So let's start with the setup and write some installations. So we're going to be needing Matplotlib, Seaborn, Pandas, and Colorama. So we need these packages mainly to run the code that's generated by the LLM, and we're going to visualize the data using, say, Matplotlib and Seaborn. Let's sort out the imports as well. So import OpenAI from OpenAI. This is mainly for the LLM we are going to be using. You can use any other LLM from, say, Gemini or any other provider, but I'm going to stick with OpenAI for this notebook. And we also going to be using NumPy in order to generate some random data points. To start with, that's about it. Let's also sort out the environment. So from .env, I'm going to import load.env, and I'm going to say load.env. That is going to load the OpenAI API key in order for our LLM to work. So next we are going to test our LLM. So I'm going to create an OpenAI client. So that's sorted out. And now I'm going to quickly test and make sure that the LLM works. So it'll be a markdown. And I'm going to say chat completion is client.chat.completions.create. Model is GPT-4o. You can use any other model that you want, obviously, because it's a simple problem. Messages is, because we are just testing it out, we're going to just wave at it saying hi, and we're going to find out if that responds fine. On the content is hello there, chat completion dot choices message dot content. No, doesn't like that. Need to open the bracket. So we got a response, meaning that the LLM is now working. We can now move on to implementation of the reflection agent. And if we look at our block, we have the generator and we also have the reflector or the reflection model. So we're going to start with the generator here. The LLM is going to take the user's prompt and just going to generate some output. Let's implement that first. So the first one is going to be that of generator. We're going to write a generator prompt. This is going to be a system prompt for the generator. And the role is going to be system, obviously. And the content is going to be that of a data analyst good at visualizing data. Use Python pandas to generate code to visualize user data. So whatever the code that it writes is going to use the pandas package from Python. We now need to mention about the feedback from reflector to the generator. So for that, we need to say, when provided with critiques, improve the code to make it more efficient and accurate and respond with a newly revised code based on the critiques improved code. So this pretty much summarizes what the generator needs to do. Now we need to pass the user prompt to the generator. So I'm going to append to the prompt and say that the role is user. And I'm going to also give the content, which is that write code to plot X and Y. I want to understand the distribution of the two data. Here's the data X and Y, but I haven't generated the data. So I'm going to import NumPy and I'm just going to generate some random data. So number of points is 20 and I'm going to say X is np.random.rand of number of points. Again, Y is the same. So we're going to generate random X and Y points and we're just going to pass it in the user prompt and we're going to get the generator response, which will be again using the client.chat.completions.create. And we need to pass the model and the prompt to get the response. So the model is GPT-4o, of course, and the prompt is going to be messages equal to generator prompts. And we will get the response. So once we get the response, we're going to extract the generated code from that. So generated code is generator response dot choices of 0 dot message dot content, and we are going to display that as a markdown, whatever we get. Just for ease of convenience of visualizing it, we are going to visualize the generated code as a markdown. Let's run this and it's still running. So I forgot to import markdown and display and hence the error. So I'm just going to go to the top and I'm just going to import that. So we have imported display and markdown. So if I run that again, and I'm going to hit OpenAI again and then give them more money. So it has churned out the code now for us to visualize the data X and Y. So let's just copy that and run it in a separate cell to visualize or to see what it has come up with. Firstly, it has come up with a working code and it has done a scatter plot of X versus Y. This is X, this is Y, and it's done a scatter plot and it's also done a histogram of X and Y. This doesn't look great actually. So let's see if we can improve this with a critique. In order to criticize on this output, we need to implement this reflect actually. So we are here where we got the response from generate. Now we need to pass that to reflect or reflector. So let's go ahead and implement this part. So right onto reflector, I'm going to say reflector, and that's going to be a markdown. And I'm going to implement that in the cell, which is going to be reflection prompt. First, I'm going to write the reflection prompt for our reflector, which is going to be the system prompt. And I'm also going to say role is that of a system and the content is this. I'm going to give a detailed instruction on what it needs to do. So there it is. So that's the system prompt for the reflection. We're going to say you are a senior data analyst. Given the code generated by the generator block, provide feedback to the generator block. The feedback should be in the form of a critique of the code, and the feedback should be a list of improvements that can be made to the code. That sounds good to me. I'm also going to pass the user prompt to reflection. So I'm just going to say reflection prompt dot append, and I'm going to append the role is that of a user and the content is that of here is the code generated by the generator block, and I'm going to provide the generated code that we got from the previous step. You can see that we got the generated code here from the generated response, and I'm going to pass that generated code here to the reflection block. And of course, what we get at the output is going to be reflection feedback. Why is it a different color? Am I doing something wrong here? So I haven't closed the brackets, so I've closed it now. Should be fine. Reflection response is still not happy with that. Yeah, seems all right now. So reflection response is client dot chat dot completions dot create, and we're going to model this once again GPT-4o, and the messages is reflection prompt. So that's the response that we will get, and whatever we get in the response is going to be that of the reflection feedback. So the feedback is reflection response dot choices of 0 dot message dot content, and we're going to display it nicely as a markdown, the reflection feedback. Let's run it. There you go. Of course, this is not client. I need client. That's running now. So this is the feedback that we got. Basically, descriptive titles and labels, additional statistical information, colorblind friendly palette, data size handling, density plot, interactive plots. And finally, it says implementing these improvements can enhance the effectiveness of your visualizations and make the data insights more accessible to wider audience. So that feedback is fair. In terms of the implementation, we have implemented this and we have now got the feedback, which is this one. And so we need to pass this to the generate in order to complete the loop. So let's go ahead and do that. We are going to be passing the response. So we are going to be passing that feedback to the generator prompt. So all we are going to do is generator prompt dot append, and we're going to append the response that we got. We're going to say role is that of user, and the content is here is the feedback from the reflection block, and I'm going to pass the reflection feedback, and I'm going to close the content here, and we're going to get the response back from the generator once again to see where it takes us. So the chat.completions.create, and the model is GPT-4o, and the messages is generated prompt, and we will be getting hopefully improved code, which I'm going to take it in another variable, generator. So that's generator response dot choices of 0 dot message dot content, and I'm going to again display it as a markdown of the improved code. So let's run that. Generator prompt is not there. Fair. So that's generator prompts with the S. So I'm just going to copy paste it to be safe. So generator prompts. So that's running now. So once we get the code from the LLM, I'm going to run that again and see if there's any improvement in the plot. So we got the response. I'm going to copy the code and just run it in a separate cell so that we can see if there's any improvement. Now it has used SciPy for no reason, so I'm just going to import SciPy. I think it's scikit-learn, and I'm going to run it again. After including scikit-learn in the installation, we scroll down. It has come up with a different plot now. We just run it. We can see that this looks much more elegant, at least the scatter plot, and the histogram, the distribution of X is this one and the Y is this one, and it is also given the mean and standard deviation. This at least looks better, far better than the plot that we got in the first iteration, which is this one. But we cannot keep going this way, writing the generator code and then taking it and manually passing it to the reflector. So the ideal way is to implement a reflection agent in a separate class. So that's what we are going to do. I'm going to call it a simple reflection agent. That's going to be markdown and right. So let's write the reflection agent in a separate class now. So we have pretty much completed this loop. We got the feedback from reflection and we passed it to generate. And we saw the generated output was better than the first iteration, but we're going to write a separate class so that this loop can continue, let's say 10 times or 20 times or whatever the number of times possible. So let's start by defining the class reflection agent is going to have init, and it's going to take a few parameters, of course, and it's also going to have generate code, which is going to belong to the class. And we are also going to have reflect on code, which is going to do the reflection function. And we also going to have improve code, which is going to improve the code that's generated by the generator. And finally, we're going to have a function to run the agent. So it's going to be run, and that's also going to belong to the class. So right, so let's start with init. Let's think about what we actually need as input. So we need the generator prompts as input for the generator, and we also need the reflection prompts, and we also need the number of steps that we need to go through in the loop. So we need the ability to define the number of steps that this, or the number of iterations that this is going to happen. And also let's have the ability to define the model that we're going to use. Even though it's going to be GPT-4o, by default we should have the ability to change the model. So this is all that we need. And let's just say generator prompt is generator prompts. Similarly, let's do the others as well. Equal to this, self.num steps is num steps, and self.model is model. So the initialization is for now sorted. Let's move on to generate code. So generate code is going to take in the user prompt, and it's going to generate the code for us. So it's self.generator prompts .append. Obviously we need to append the user prompt to the generator prompt because the role is different for the user. So the role is now user, and we are going to append the content of which is the user prompt. So the user prompt is done, and we need to get the response with this prompt. So self.client.chat.completions create obviously the model, which is the self.model, and the messages is self.generator prompts. So we will be using this prompt to actually generate code, self.generated code. Let's store the generated code in a variable and call it generated code, which we haven't declared. I'm going to do that now. So first let's get the response. Response.choices of 0. Message.content, and this one obviously needs to be initialized. Self.generated code is none. Also, we will note that there is self.client, which means we need to have the client, which we don't. So the client would be self.client is OpenAI. So every time we initialize an agent, it's going to be initialized with the client and then the model, which is GPT-4o or whatever that we pass inside that. So generate code is now complete with that. Whatever the code is generated, the reflector has to reflect on that. So we need to write the reflect on code. It's not going to take any parameters, but then it's going to do self.reflection prompts .append, and is going to append the role as user, and also the content is obviously here is the code generated by the generator block, and we're going to provide the code. We're going to do self.generated code that we have declared here, and also we have got it from the generate code. We're going to pass that to the reflect on code. So once we do that, we need to, oh, what am I doing wrong? I haven't closed the braces. Yeah, we need to get the response now. So response equal to self.client.chat.completions create, and I'm going to do model is self.model, and messages is self. This time reflection prompts, and then we need to get the feedback, reflection feedback. Reflection feedback is nothing but the response that we get, more specifically response.choices of 0.message.client. And let's do something. Let's also save this to the class. So self.reflection feedback, and I'm going to say self.reflection feedback is none. I'm going to initialize that when I create the agent, and I'm going to say self.reflection feedback is going to be populated when we reflect on the code. So we'll generate the code, we will reflect on it, and we need to improve the code. So improve code is going to basically improve the generated code. So let's do that. So the improve code is going to again work with the generator prompt. So generator prompts dot append model is self.model. Now role is user. The content is, here is the feedback from the reflection block, and we will pass the reflection feedback that we stored here in the when we did the reflection. So we're just going to pass that to improve the code, and we're going to get the response passing that. So response again is self.client.chat.completions.create. Model is self.model, and messages is self.generator prompts. So the generator prompts is used because we're dealing with generating code here, and we're going to get the response from that and store it in improved code. Self.improved code is equal to response.choices of 0.message.content. And self.improved code, have we initialized that? No, I haven't. So self.improved code is none. So self.improved code is also declared now. So with those things done, it's time to define the function to run the code. So the class can now generate the code, reflect on it, improve it. Now it's time to actually run the agent. Basically, this is where we are actually going to do this loop. The main reason we are implementing this class is because we want this loop to be run as many times as we want, and the best place to define that is in run. So we're going to say for step in range of self.num steps, and we'll iterate through that many steps in the run. But before that, let's get the generated code. So self.generate code of user prompt, and obviously we need to get the user prompt here as the input. Basically, whenever we run the agent, we're going to start with the user prompt, and with that user prompt as the first step, we're going to generate code. And once we have generated the initial code, this is like initializing a loop. So once we have initialized the loop, now we need to loop through and go through the reflection and improvement steps. So I'm going to say self.reflect on code, and then I'm going to say self.improve code, and I'm going to say whatever is improved is going to get stored in self.improved code. And so I'm going to update the generated code. Self.generated code is the improved code. So I hope that makes sense. This is pretty much the loop, reflection loop that we need to implement. As the first step, we are generating the code, and once we have the initial code generated, we reflect on it, we improve it, and update the improved code to the generated code. And again, we go through the loop as many times as we want, which is defined by the number of steps. Well, this is more like a black box. If we run this 10 times, we really don't know what's going on in the middle, because this loop is going to run a few times. So let's just print some stuff. I'm going to say 4 dots, just beautifying the output. And I'm going to say generated code, and I'm going to print the generated code, of course. And then after the reflection on the code, I'm just going to do the same thing. Just going to copy paste to be quick. So instead of the generated code, I'm going to say reflection feedback, and I'm also going to include the step just to know that which step we are in, and also going to change this to reflection feedback. And after the improved code, again, I'm going to paste the same stuff, and I'm going to say improved code is the step, and I'm going to print the improved code instead of the generated code. I don't know why I'm searching for that, but anyway, so we have it. And I think printing these few lines is going to give us an idea of what's going on in the middle of the loop. By doing so, we have pretty much implemented the reflection agent. We have written code to initialize it. We have written code to generate the code. We have written code to reflect on the code. And we have also written code to improve the code. And we have also written the code to run the agent in a loop where we define the number of steps. So it's now time to test the agent. We're going to say test the agent. And after that line, I'm just going to initiate the agent, which is, well, let's just execute the cell to make sure that the class is running fine. You can see that there's already some error there. So the content is, that needs to be a colon, execute it again. Yeah, that went through fine. So the class is now there. So we say reflection agent, and I'm going to say generator prompts equal to generator prompts, and reflection prompts is reflection prompts, and the number of steps is going to be 3. I'm going to restrict to 3 steps, but before that we have never defined the generator steps, generator prompts, and the reflection prompts. So let's do that. Generator prompts is pretty much the same prompt that we defined before, so I'm just going to copy paste that. So I've copy pasted what the generator prompt should do. It's the data analyst good at visualizing data, use Python pandas to generate code to visualize user data, and the reflection system prompt as well. I've exactly copy pasted what we defined before. That's the reflection prompt, and we're going to pass that to the agent. And once we have created the agent, we can create some data. So let's do that. We are creating the agent. So it's not num steps, is it? So it's num steps. There you go. So we have created the agent now, and we can now generate some sample points. Let's say number of points is 20. That's the input points. X is equal to random points. I'm basically generating input points to pass to the prompt. So we have generated the data, and the user prompt is going to be write me code to visualize this data in a bar chart. And here is the data, and I'm going to pass X as this, and Y is the other data that we generated. So there is the user prompt, and it's time to run the agent. Agent.run user prompt is user prompt. So that's going to take a while because it needs to go through 3 iterations of the loop. Every time it needs to generate, reflect, and also it needs to improve the code. So it has completed running successfully, and we can see that initially there's generate code, and it is given the Python code in pandas to do a plot of the input data, and it is also got critiques and potential improvements, and there is reflection feedback in step 0. And here are the several points where improvements can be made. That comes from the reflection agent, and there are quite a few things that are listed there. And once that is done, then there's improve code in step 0 that's running, and it says show let's incorporate the feedback to improve the visualization code. And so it is giving us the improved code. We can see that the code is much longer. I'm going to execute towards the end, but I'm just walking through now what's happening. And then there's reflection feedback step 1. Again, there's a bunch of feedback there. There's improved code in step 1, and we again have the improved code that's churned out. And again, there's feedback step 2. There's a bunch of feedback there, and we have the improved code in step 2. Again, there's code that is churned out that is improved compared to the previous iteration, and eventually it lists the key changes implemented. Let's take one of the iterations and run and see how it does. So I've copied the code, I'm pasting it, and I'm just running it. So if you look at the generated code in the first iteration, so this is what has happened. It has plotted both the data X and Y next to each other, and has shown us clearly because we just generated random points. It has shown exactly that. They're all completely random without any pattern. Now what I'm going to do is copy the result of the first iteration of the improvement loop, and I'm just going to copy and paste that code. Let's see what happens. So this is the plot after I copy pasted that. We can see that the color scheme has improved, and overall aesthetically it looks slightly better than the previous one. So that's exactly what I wanted to show in this video. We implemented a reflection agent. We started by implementing each of the blocks as small code snippets, and then we put together everything in a loop, and we wrapped everything in a class, the class named reflection agent, and we did everything in raw Python, and that seems to be working. So with that, I would like to wrap up this video. I hope that is useful, and I will see you in my next video. Take care.